In this video, we are going to talk about polar coordinates. First, we will talk about how to represent points in polar axis, and then we'll talk about how to convert from the Cartesian coordinates to polar coordinates. And lastly, we'll talk about how to convert from polar coordinates to Cartesian coordinates. So let's assume that we are having the point 2 and then pi over 4. How do you represent 2 and pi over 4 on the polar coordinates? Sorry, on the polar axis. So let's draw the polar axis. So what is pi on 4? Pi on 4 is the same as 45 degrees. So in other words, 2 units and 45 degrees. So we'll first have to measure 45 degrees, which is pi on 4. So 45 degrees will just be here's 90 degrees. So 45 degrees will be in the middle. And then it should be 2 units. So if this is 1 unit, then here will be 2 units. So this is the point. Let's say P, 2 and pi over 4 on the polar axis. So here is pi over 4. What if we were given the point -2 and then pi over 4? So -2 is just the direct opposite of this. So that will be in this plane. Anytime you are given polar coordinates r theta, and r theta is given as minus r theta, then you can represent it in the polar coordinates by adding pi to theta. So minus r theta is the same as r and then theta plus pi. So in this case, it is pi over 4. And then pi over 4, we add pi to it. That will give us 5 pi over 4. And 5 pi over 4 is in this quadrant. So here is 1 unit, and this is 2 units. So this place will be pi over 4. And so this is the point. Let's say P given as -2 and then pi over 4. What if theta was given as 2 and minus pi on 4? So this is pi on 4. If you are moving in the anti-clockwise direction, then pi is supposed to be taken as positive. But if you are moving in the clockwise direction, then the values that pi takes are negative. And therefore, minus pi on 4 will just be here. So this is 1 unit, and this is the second unit. So here will be minus pi on 4. So this is the point P, 2 and minus pi on 4. So this is how to represent points in the polar coordinates. Plot the points whose polar coordinates are given by into bracket 2 and pi on 4, 3 and minus 3, whose points are given by 2 and pi on 4, then minus 3 and 3 pi on 4, and then here is 2 and 5 pi on 2. So let's consider this polar axis, and let's assume here is 0 degrees. So we'll start adding. If here is 0 degrees, then this is pi on 4. Now if you add pi on 4 to another pi on 4, here will be pi on 2 plus another pi on 4. We'll get 3 pi on 4. Then plus another pi on 4, here will be pi. Then pi plus pi on 4 is the same as 5 pi on 4. Then 5 pi on 4 plus pi is 3 pi on 2. Then 3 pi on 2 plus pi is 7 pi on 4. Now, let's assume here is 0. So let's assume that the circle within, which is this small circle, is 1 unit. The one outside is 2 units. And then the very outer one is 3 units. So the first polar point we are given is 2 units and then pi over 4. So you see that this is pi over 4 and then this is 2 units. So 2 units and pi over 4 will be here. And then the second one is minus 3 and 3 pi on 4. So you see that the outer one is 3. And then which side is 3 pi on 4? This is 3 pi on 4. But since he said minus 3, so minus 3 and then 3 pi on 4. Anytime you see the r equals minus r, then you can plot it by adding pi to theta. So it becomes theta plus pi. And therefore this becomes 3 pi on 4 plus pi. And 3 pi on 4 plus pi is 7 pi on 4. And therefore 3 and then minus 3 and 3 pi on 4 will be here. So the outer one is 3 units and 3 pi on 4 will be this point. So let's come to this point, which is 2 and 5 pi on 2. 5 pi on 2 is greater than 2 pi. That means that if we are moving in terms of the angle, then we would have moved 2 pi. So if we move 2 pi, what will be left? We will be able to do that by just subtracting 2 pi from 5 pi over 2. And this will give us pi on 2. So 2 and pi on 2. So this is 2 and pi on 2. And therefore, this becomes a point 2 and then 5 pi on 2. Let's talk about how to convert from Cartesian coordinates to polar coordinates. So if we are given minus 1 and root 3, how do we convert minus 1 and root 3 to polar coordinates? Remember that polar coordinates is giving us r theta. So we need to first find r. And then r is equal to the square of each of the coordinates added together. So here we can minus 1 squared plus root 3 squared. So r is equal to minus 1 squared is 1 plus root 3 squared is 3. So r is equal to root 4, which is equal to 2. Then the next thing is, let's represent this on the Cartesian coordinates. So here's x and here's y. So let's assume that here is minus 1 and here is root 3. Here is minus root 3 and then this is 1. So it is minus 1 and root 3. So this is root 3 and here is minus 1. So minus 1 root 3 will fall somewhere here. So if we join them together, here is r and then it makes an angle theta. So if we join this together, you will see that tan theta is equal to the opposite, and the opposite in this case is root 3 divided by the adjacent, and the adjacent is 1. So theta is equal to tan inverse of root 3, and tan inverse of root 3 is equal to 60 degrees. Now 60 degrees in terms of pi radian is equal to pi over 3. But remember that we are moving all the way from here to this place. So from here to here is the same as 1 pi minus pi over 3. So alpha is equal to pi minus pi over 3. And pi minus pi over 3 is equal to 2 pi over 3. So in terms of polar coordinates, then minus 1 and root 3. Sorry. In terms of polar coordinates, minus 1 and root 3 will be given as the r is 2 units and then the angle is 2 pi over 3. Now let's convert 2 to polar coordinates. So let's find r. R is equal to square root of 2 squared plus 2 squared. So r is equal to root 4 plus 4, and this is equal to root 8, and r is equal to 2 root 2. Now let's sketch 2 root 2 in Cartesian plane. So here is x and then here is y. So here is 2 and then this is 2. So 2, 2 will be somewhere here. And let's join them together. So the angle is here, theta. So tan theta is equal to 2 over 2. And therefore theta is equal to tan inverse of 1. Therefore theta is equal to 45 degrees. And 45 degrees is the same as pi over 4 degree radians. So this part is pi over 4. So in terms of polar coordinates, then 2, 2 is given as 2 root 2 and then pi over 4 radians. Now, what if it was 1 and minus root 3? How do you convert 1 and minus root 3 to polar coordinates? So let's find r. R is equal to square root of 1 squared plus minus root 3 squared. So r is equal to square root of 1 plus minus root 3 squared is 3. So r is equal to root 4, and therefore r is equal to 2 units. Let's sketch this on a Cartesian plane. So if we sketch it, this is x and this is y. So 1 is here, and then let's assume here is minus root 3. So 1 minus root 3 will fall here. So the angle here is theta. So tan theta, let me solve it here. Tan theta is equal to the opposite, which is root 3 over adjacent 1. So theta is equal to tan inverse of root 3. And therefore theta is equal to 60 degrees. But 60 degrees is the same as pi over 3 radians. So this part is pi over 3. Now, if we move in this, from this axis in the clockwise direction, then r theta is going to be given as, we got the radians as r as 2. So 2, sorry, let me write it here. We got it as 2, and because we are moving the clockwise direction, it will be minus pi over 3. So we can represent it like this. Or if we want everything to be in the positives, then minus pi over 3 is the same as measuring in the clockwise direction to this point. So alpha will be equal to, you subtract this minus pi over 3 from 2 pi. So it will be 2 pi minus pi over 3. And 2 pi minus pi over 3 is the same as 5 pi over 3. So this is 2 and minus pi over 3, or you can write it as 2 and then 5 pi over 3, because theta is 2 pi periodic. Now let's talk about how to convert from polar coordinates to Cartesian coordinates. So if you are given 3 and pi over 4, what is 3 and pi over 4 in Cartesian coordinates? You find the x component by using x equals r cos theta. And then you find the y component by using y equals r sine theta. So this is just going to be x equals 3 cos pi over 4. And this is the same as 3 root 2 over 2. And then y is equal to 3 sine pi over 4. And 3 sine pi over 4 is 3 root 2 over 2. And therefore 3 and pi over 4 in polar coordinates is equal to 3 root 2 over 2, then 3 root 2 over 2 in Cartesian coordinates. What if it was minus 4 and then minus pi over 4? How do we convert this into Cartesian coordinates? Now remember that because here is minus 4 pi, what we will do is that we need to add, we can convert this to the positive. So you can convert minus r to r by adding pi to theta. So minus pi over 4, all we need to do is to add pi over 4. So alpha is equal to minus pi over 4 plus pi. And minus pi over 4 plus pi is the same as 3 pi over 4. So it means that the x coordinate will be equal to 4 cos 3 pi over 4. And this is equal to minus 2 root 2. And then the y coordinate will be equal to 4 sine 3 pi over 4. And this is also the same as 2 root 2. What if the point that we're given was 3 and minus pi over 3? How will we convert this into Cartesian coordinates? So it's the same thing. Now, since here is minus pi over 3, we can convert it to a positive angle by adding 2 pi because theta is 2 pi periodic. Now, get the difference between these two. Here, our focus was on r, but here our focus is on theta. If r is negative, convert it to positive r by adding pi. But if theta is negative, convert it to positive theta by adding 2 pi. So alpha is equal to minus pi over 3 plus 2 pi. And this is equal to 5 pi over 3. So therefore, the x component is equal to 3 cos 5 pi over 3. And this is equal to 3 over 2. And then y is equal to 3 sine 5 pi over 3. And 3 sine 5 pi over 3 is equal to minus 3 over 2 root 3. So therefore, in terms of polar coordinates, 3 and then minus pi over 3. Sorry, in terms of Cartesian coordinates, is the same as 3 over 2 and then minus 3 root 3 over 2.